Welcome to PROFINET Basics. This course covers the following topics: PROFINET overview, device types, profiles, transmission modes, network topologies, connection technologies, addresses, diagnostics, security, and user benefits. The focus of this course is on PROFINET concepts and terminology and not implementation knowledge and skills. This course is recommended as a prerequisite to more advanced training, but it can also be helpful if you simply want to learn basic concepts. This chapter has provided you with an overview of PROFINET and the device types and some important profiles associated with this network. The concepts and terminologies discussed in this chapter will be useful to you in the remaining chapters of this course. This information is also important to understanding why PROFINET has become the market-leading industrial Ethernet system. As you are probably aware, a field bus is a type of industrial network used for distributed control, and PROFIBUS is an open field bus standard of PROFIBUS and PROFINET International, PI. Since its initial development in the late 1980s, PROFIBUS in its various forms, PROFIBUS DP for discrete automation and PROFIBUS PA for process automation, has become the world-leading field bus based on its widespread use and support from many suppliers. In recent years, shorter implementation cycles and the drive for increased productivity and reduced costs have forced companies to take another look at their network designs. Some of the key questions they are asking are: how can I simplify system engineering? How can I expand existing systems while protecting previous investments and taking advantage of accumulated know-how? How can I more effectively integrate IT networks and standards with real-time control applications? How can I improve system diagnostics and increase system uptime? Increasingly, one network, PROFINET, stands out as the answer to all of these important questions. PROFINET is the open industrial Ethernet standard of PROFIBUS and PROFINET International, PI, and the leading industrial Ethernet standard worldwide. As such, it uses proven IT standards, making plant-to-office communication straightforward. PROFINET is available in two compatible forms. One form is PROFINET CBA, which stands for Component-Based Automation. The focus of this course, however, is the more common form, PROFINET IO, which stands for Input-Output. The strength of the PROFINET IO design is that it handles non-time critical IT communications well, while also simultaneously accommodating the full range of real-time control communications. But this is only part of the story. Let's take an introductory look at PROFINET IO, which in most instances we shall simply refer to as PROFINET. A communication protocol is a set of rules or procedures for communicating. Non-time critical communications over an industrial Ethernet system are typically referred to as TCP/IP communications because of two common protocols used: Transmission Control Protocol, TCP, and Internet Protocol, IP. While these protocols work well for many IT functions, control-related communications need more deterministic approaches for handling time-critical data. Fortunately, PROFINET not only allows TCP/IP communications, but also supports two performance levels of real-time communications for time-critical data. For many control tasks, PROFINET real-time RT communication provides a deterministic approach that works well. For the most time-sensitive tasks, PROFINET isochronous IRT communication is well suited. By virtue of its ability to handle control tasks, PROFINET extends the benefits of standardized Ethernet communication to distributed field devices. This approach allows field devices from many suppliers to be easily connected to the network. At the same time, PROFINET protects existing investments by simplifying integration of existing PROFIBUS networks. As previously mentioned, PROFINET allows for isochronous real-time IRT communication, which meets even the most exacting requirements of motion control applications. This extends the range of motion control applications beyond what could previously be handled using field bus networks. Because PROFINET is the open industrial Ethernet standard of Profibus and PROFINET International PI, and is the leading industrial Ethernet standard worldwide, it can function as a distributed automation network throughout the plant. Because PROFINET uses switched Ethernet, it has the flexibility to accommodate multiple network topologies. Furthermore, PROFINET devices can be interconnected via copper or fiber optic cables or Industrial Wireless Local Area Network, IWLAN. These capabilities allow PROFINET to meet the requirements of a wide range of applications. But despite this broad application range, PROFINET networks are quicker and easier to start up due to the adaptive nature of PROFINET devices. PROFINET relies on established standards from the IT world in many areas. In addition to allowing simultaneous IT communication on the same network as control communication, this also allows web servers or other IT services to be on PROFINET devices. In addition, through use of standard IT security approaches, a PROFINET network can be designed to reduce security risk to production areas and other sensitive places. The ProfiSafe profile permits the transmission of standard and safety-related data on a single bus cable and can be used with PROFINET or PROFIBUS. This means that no special network components are required for fail-safe communication. The benefits of PROFINET are not limited to factory or discrete automation applications. PROFINET is also widely used in process control applications. This makes PROFINET the standard for all automation applications. What do you think? Drag the terms in the blocks to match the corresponding statements. Then click Evaluate. What do you think? Drag the terms in the blocks to match the corresponding statements. Then click Evaluate. As you have seen, PROFINET is an advancement from PROFIBUS. To understand that better, consider the following network characteristics. PROFIBUS is a field bus, which means that it is intended for distributed control communication. PROFIBUS is a master-slave system, which means that a slave device cannot communicate until requested to do so by its master device. A PROFIBUS master can control up to 125 slave devices. PROFIBUS primarily uses copper or fiber optic cables, but infrared communication is also supported. PROFIBUS has a maximum data rate of 12 megabits per second. By comparison, PROFINET is an industrial Ethernet network with the ability to handle both TCP/IP communication and distributed control communication. PROFINET is a producer-consumer system, which means that devices can independently send and receive data. Data collection and device configuration are simplified, and network performance is improved. In a PROFINET system, the number of nodes, devices, is not restricted. PROFINET uses copper or fiber optic cables, but also supports Industrial Wireless Local Area Network, IWLAN, communications. And finally, PROFINET has a maximum data rate of 100 megabits per second. The accompanying illustration shows the various device types associated with PROFINET and PROFIBUS. Keep in mind that for any of these device types, many specific devices from many suppliers could be used. To gain a better understanding of the differences between PROFIBUS and PROFINET, Consider the functions of the Profibus device types shown in comparison to the following PROFINET device types: I/O controller, I/O device, and I/O supervisor. Profibus is a master-slave network with two classes of master devices. Most communication is handled by a Class 1 master, which is often a programmable logic controller, PLC. A Class 1 master controls all communication with its slaves. Most of this communication is handled through a cyclic polling process. Slaves do not initiate communication. They respond to requests from the master. Profibus also allows a Class 2 master, which is often a programming device or other type of computer. A Class 2 master is used for configuration, maintenance, and diagnostics. A Class 2 master can communicate with Class 1 masters and their slaves. By comparison, a PROFINET system includes at least one I/O controller with I/O devices assigned to it. The I/O controller is typically a PLC or other control system which configures the I/O devices and exchanges data with them, but does not control their communication. An I/O device is typically an input-output device connected to the process. Another type of PROFINET device shown in the accompanying illustration is an I/O supervisor, which is often a programming device, human-machine interface HMI, or personal computer PC. The I/O supervisor is used for commissioning, monitoring, and diagnostics. The remaining pages of this lesson summarize the other device types shown. A proxy is a device that connects a PROFINET network to a field bus, Profibus in this example. Because the proxy maps the subnetwork to PROFINET, all the devices of this subnetwork are available for PROFINET communication. A proxy protects investments in existing systems by simplifying integration of existing Profibus networks while also making the advantages of PROFINET available during plant upgrades or expansion. The PROFINET device types previously described have been part of the system since its inception. Later innovations added to the PROFINET I/O capability include two new device types, shared device and iDevice. As the accompanying illustration shows, the shared device capability allows two I/O controllers to use the same I/O device. This capability is accomplished easily by copying the configuration from one I/O controller to another. The benefits of this approach are reduced costs for equipment engineering, installation, and maintenance. The shared device capability can be useful in a number of situations, but one of the more obvious applications is use of a standard PLC and a fail-safe PLC with the same I/O devices. This approach is especially beneficial for demanding applications where separating these controller functions can improve system performance. iDevice is short for Intelligent Device. An iDevice is a local I/O controller that also functions as an I/O device for a central I/O controller. This means that the central I/O controller has direct access to the I/O image in the local I/O controller, so communication is simple and fast and no complex programming or additional communication hardware are required. The iDevice capability can be used in many applications, but is especially useful for modular machines and distributed controller applications. As an additional PROFINET innovation, the iDevice and shared device concepts can be combined in an application. For example, an I/O controller functioning as an iDevice can have some of its modules accessed directly by higher-level controllers. This allows for additional flexibility in the design of modular machines and systems. What do you think? Drag the terms in the blocks to match the corresponding statements. Then click Evaluate. Profibus and PROFINET International (PI) has established working groups with representatives from a number of companies. These working groups are responsible for specifying configurations of Profibus and PROFINET devices that meet special requirements. The specifications covering these configurations are published by PI as profiles. Profiles are designed to be open and vendor neutral so that users can incorporate products from multiple suppliers into their systems without concern for interoperability. Another way to think about a profile is as an agreement among suppliers to produce products that comply with the profile specification. In support of these profiles and other specifications, PI has established competence centers and authorized test centers worldwide. Additionally, PI and its regional organizations, member companies, and other organizations, including C-Train Training for Industry, provide training and support. Throughout this course, we will be discussing the PROFINET IO profile. The following additional PI profiles are summarized in the remaining pages of this lesson: ProfiDrive, ProfiSafe, and ProfiEnergy. ProfiDrive and ProfiSafe were initially developed as PROFIBUS profiles and later extended to include PROFINET. ProfiEnergy is a PROFINET profile. Electronic drives are used in a variety of applications ranging from control of pumps, fans, and compressors to complex motion control. The ProfiDrive profile allows users and OEMs to design machines and processes with drives from multiple suppliers communicating via PROFIBUS or PROFINET. Use of this profile ensures that systems can be later modified or expanded while retaining compatible communications. Additional benefits can be obtained by combining the ProfiDrive profile with other profiles such as ProfiSafe and ProfiEnergy. Integrated safety is a design approach that integrates safety devices and systems with standard automation. While machine and process safety has always been important due to the inherent risk posed by manufacturing operations, use of integrated safety technologies have increased significantly, in part due to new safety standards, but also due to technological innovation. ProfiSafe is an integrated safety technology applicable for both discrete manufacturing and process automation, which permits the transmission of standard and safety-related data on a single bus cable. Because many suppliers cooperated in the development of this profile, a vast array of compatible products and systems are available. Over and beyond the many benefits associated with the use of integrated safety, use of ProfiSafe technology benefits users and OEMs by simplifying engineering, installation, and commissioning. In addition, as with other PI profiles, use of ProfiSafe protects investment by ensuring that systems can be modified or expanded without compatibility complication. Reduction in energy consumption has long been a goal of manufacturers due to the significant financial impact of energy costs. In recent years, the drive for more sustainable operations and the need to comply with environmental regulations have increased interest in technologies that can further reduce energy consumption. The ProfiEnergy profile enables the design of systems with controllers such as programmable logic controllers, PLCs, that can signal equipment, referred to in the profile as energy-consuming units, ECUs, to begin a sleep mode at the start of a planned pause or unplanned work stoppage. Software in each ECU determines how the sleep mode is implemented. When the sleep mode is over, the controllers signal the ECUs to resume operation. For example, the accompanying graph shows energy usage over time for a system with standard automation. Time A is representative of an unplanned work stoppage that could occur due to any number of production line issues. Times B and C are representative of planned pauses such as a lunch break or end of shift. Next, note the energy savings in graph 2 for a similar system that adheres to the ProfiEnergy profile. While these graphics are only intended to symbolically explain the benefits of the ProfiEnergy profile, the actual cost benefits are real and documented. What do you think? Select all the correct statements, then click Evaluate. This chapter has provided you with an overview of PROFINET and the device types and some important profiles associated with this network. The concepts and terminologies discussed in this chapter will be useful to you in the remaining chapters of this course. This information is also important to understanding why PROFINET has become the market-leading industrial Ethernet system.